Hey everyone, welcome back to the channel Code with AKJ. Today is day 34 of solving Geeks for Geeks problem of the day. Today's question is parenthesis checker. So the question says given an expression string x, examine whether the pairs and the orders of these brackets are correct in expression. For example, the function should return true for expression given here and false for expression given here. So note here would be the driver code prints balanced if function returns true, otherwise it prints not balanced. So today we are solving an interesting problem called parenthesis checker. We'll check if pairs and orders of parentheses like opening and closing brackets are correctly balanced or not. So let's dive into it. So give an example here. So we need to find a way to verify that these brackets are correctly ordered. So the example for a balanced string would be something like this, where the order of each and every parenthesis is correctly maintained, and here the curly braces is maintained properly with its particular pair here, and the circular brackets is maintained properly with its pair, and the square brackets are maintained properly related to its pair. So in this example we can say that this is a balanced parenthesis, so we return true in this case. Coming to the second example, the output here would be false as the pairs are incorrectly ordered here. So in the brute force approach, we'll scan through the string and manually track the opening and closing brackets. This involves checking each pair of brackets and ensuring that they match. So first, what we can do here is iterate over the string, and for every closing bracket we'll check if it is matching with the last unmatched opening bracket. So here we'll take a variable temp which will store the string, and we'll run a loop over this string, and we'll add this particular character to our string. For example, here for every opening character we'll add to our temp variable. Here the first character would be the opening bracket and second character will be the opening bracket, and whenever we encounter a closing bracket we'll check the last character of our temp variable. So if it matches with its particular pair, then we'll pop it out this last character. If not, we'll return false there. So let's try to code this approach and let's check whether it gets accepted or not. So this is a code for the brute force approach we have discussed, where we have taken an external variable temp which generally stores each and every character, and with the help of this we'll check for every closed bracket we'll check the last character of this temp string, and if it matches with its particular pair then we can move on to the next character, or if not we'll return false here. So here I've taken a string temp which would be initially empty, and I've iterated over the string x, and if we found any opening character we'll add it to the temp string, or else we'll initially check before popping out the last character. We'll initially check that if the temp is already empty or not. So if it is empty, that means it is an unbalanced string and will return false from there. So if not, we'll retrieve the last particular character from the temp string and we'll check with its current character. So if it matches with its particular pair, we'll return true, or else if it not matches with its particular pair in a proper order, then we'll return false here. So if it any case, since we have three different variations of parenthesis, we'll check these three conditions. If any of this fails, we'll return false from there. If it matches, we'll pop the last particular character, and finally we'll check if the temp string is being empty or not. If it is empty, then we can say that the particular parenthesis string is balanced, or else we can return false from there. So let's compile and run. So let's submit. As you can see, this problem got solved successfully. Here the time complexity would be O of n as we are iterating over the string, and space complexity would be O of n as we are using an external variable here which stores the size of a string. So here it would be O of the size of the string as our expected time complexity and auxiliary space. So a more optimal way to solve this problem is by using a stack. A stack generally help us efficiently manage the opening and closing brackets here. So we'll push the opening brackets onto the stack and pop them when we find a matching closing bracket. So here the process would be same. We'll start by iterating over each character of the string here. So if it is an opening bracket, we'll push it onto the stack in this way. And when we encounter a closing bracket, we'll check the top of the stack whether it is matching with its particular pair or not. So if it matches, we'll pop it up from the stack and we'll continue with the next element. So here, as we reached here, it has a matching pair. So we'll pop this character from the stack and we'll move on to the next character. So again, we found a closing bracket. So we'll check the top of the stack. So here it matches with the same bracket. So again, we'll pop this character from the stack. So finally, after iterating over the string, we'll check the stack is empty or not. So if it is empty, it means it is a balanced string. If it is not empty and it contains character, it means it is an unbalanced string. So in this way, with the help of stack, we can easily manage the opening and closing brackets. So this approach also runs in O of n time complexity, but it is more space efficient compared to the brute force approach we have discussed. Here the edge cases would be what if the string starts with a closing bracket or ends with an opening bracket. So in this particular edge case, the stack helps us handle these cases properly. So let's move on to the code and let's see whether it gets submitted or not. So this is a code for the optimized approach we have discussed, where we have used the external data structure stack which help us manage efficiently these opening and closing brackets, and it also manages our edge cases where the starting character could be the closing bracket. So here we'll iterate over the string, and if we found any opening parenthesis, we'll push it onto the stack, and if not, we'll initially check if the string is empty or not before popping out. If it is empty, we'll return false from there, and if not, we'll check the top of the stack's character with current character. If it matches with its pair, we'll move on to the next character. If not, we'll return false from there. And finally, we'll check the stack is empty or not. If it is empty, it means the string is balanced. So if it is not empty, it means the string is not balanced. So we return false from there. So let's compile and run this. So let's submit. As you can see, this problem also got solved successfully. So finally, to sum up, we learned how to check if parentheses are balanced or not using both brute force and optimal stack based approach. So I hope you found this explanation helpful. So please don't forget to like, subscribe and hit that bell icon for more coding problem solutions. See you in the next one. Thank you.